Welcome to this explainer. Today, we're embarking on a journey of elemental transformation, a real deep dive into the hidden marvels of modern mobility. It's a story of raw earth, intense heat, immense pressure, and some truly cutting-edge science. If you look closely at the vehicles navigating our world right now, from family sedans to heavy electric vehicles and massive freight trucks, there's literally just a single, crucial point of contact keeping them tethered to the earth. So, we're going to explore the life of a tire, specifically tracing the engineering journey of Hankook. We'll chart its evolution from a microscopic concept in a high-tech laboratory all the way to its ultimate trial by fire on the grueling asphalts of global raceways.
To really understand the sheer scale of the protagonist in our story, we have to look at the numbers. Over 104 million tires. That's how many are produced by Hankook every single year. I mean, just imagine that scale for a second. That is an absolute mountain of precision engineering, churned out by state-of-the-art automated manufacturing facilities, distributed across more than 180 countries, and connecting millions of lives to the road every single day. It's this massive global symphony of logistics, raw materials, and relentless quality control, catering to everything from everyday passenger cars to heavy commercial vehicles, and even high-performance motorsports. But before these millions of tires can roll off an assembly line, they first have to be imagined, formulated, and engineered. All right, Section 1. Birth at the Technodome.
Okay, let's dive right into this. Deep in Daedok Innopolis, South Korea, sits the Hankook Technodome. Sitting on a massive 70,000 square meter footprint, this architectural marvel honestly looks and operates like a futuristic spaceship. It serves as the global brain center for the company's research and development, and actually oversees 4 other global research institutes in the US, Germany, China, and Japan. This place is the incubator. It's where proprietary technologies are born and where visionary engineers working in these incredibly cutting-edge automated labs first introduce raw rubber and chemical compounds to their ultimate purpose.
Moving right along into Section 2, Anatomy of a Tire. So, zooming all the way down to the microscopic level, a tire is actually a highly complex chemical recipe. It all begins with carbon black, these microscopically small, highly structured particles that get blended into an optimized rubber matrix. Think of it kind of like mixing ultra-fine, super tough sand into bread dough. This super abrasion carbon black gives the tire incredibly low rolling resistance, which ultimately delivers high mileage for the driver. But the chemistry doesn't stop there. The way this rubber is baked or cured is just as absolutely crucial. By using an exact optimized curing temperature, engineers ensure the tire maintains a perfectly stable shape and boasts incredible long-term aging durability. It's quite literally chemistry actively working to conquer time and friction.
Now, beneath that rubber surface lies what we can call the structural armor. The tire is reinforced with a skeleton of woven steel cords, known in the industry as one-belt and two-belt constructions. Having a stronger bond between these internal steel layers is essential. It's what sustains heavy vehicle loads and guarantees your driving stability when you're traveling at high speeds. To further maintain that perfectly stable shape, a specialized belt edge tape is applied over it. Combine that internal steel skeleton with high-stiffness groove designs to handle immense weights and straight rib blocks on the shoulder to actively cancel out frictional noise, and you've got a structure that is as strong as it is silent.
Now, what's really interesting about this slide is the microscopic geometry at play. By applying a 3D point effect directly on the edges of the rubber tread blocks, engineers can radically improve the solidness of the tire. I know, it might seem like a tiny, almost invisible design choice, right? But keeping those rubber blocks stiff and unyielding under immense forces is exactly what allows the tire to deliver optimal handling and sharp, super responsive braking ability. It's a perfect example of how microscopic engineering yields massive macro safety out on the road.
Because let's face it, when sunny skies turn into heavy rainstorms or even unpredictable winter blizzards, this microscopic engineering becomes your real-world weather defense. Look at this, it's almost like an X-ray deep dive. Notice those 4 wide main grooves running the circumference of the tire's surface? They act as high-speed canals. When water or slush hits the highway, these grooves rapidly channel those elements completely away from the contact patch. This entire system prevents hydroplaning and grants the driver superior handling performance, even in the most treacherous, wet and freezing conditions imaginable.
Which brings us to Section 3, the ultimate proving grounds.
Okay, so the tire has been designed, chemically formulated, and structurally armored. Now it has to face its ultimate trial by fire. Just let this number sink in for a second. 1.26 million square meters. To put that staggering figure into perspective, this testing facility is the size of 125 football fields combined. This isn't just a test track. It is a sprawling, meticulously engineered ecosystem designed to push rubber and steel to their absolute breaking point. And here it is, sprawling across the landscape, the Hankook Technoring in South Korea. It's one of the largest and longest tire test tracks in all of Asia. This massive network comprises 13 independent testing roads, and this facility is built to accommodate literally every type of vehicle imaginable. We're talking everyday passenger cars to heavy commercial trucks, buses, and specifically testing against the massive instant torque and heavy weight of modern electric vehicles. This is exactly where theoretical engineering meets hard reality.
Moving to Section 4, Performance Under Pressure.
So the crucial point is that out on the track, the tire faces intense strain. Safety is heavily regulated, and indoor laboratory testing pushes these tires to the brink to earn their speed certifications. Complying with strict international standards, tires are spun continuously to simulate maximum velocities. This procedure scientifically confirms the absolute limits a tire can safely sustain. For instance, a Category G rating guarantees safety up to 90 km per hour, about 55 miles per hour, while J handles up to 100 km per hour, roughly 62 miles per hour. This testing ensures that long before a tire ever hits the highway, its speed designation is an absolute guarantee of structural integrity at incredibly high velocities.
Meanwhile, back in the lab, incredibly advanced sensors are capturing these vibrant pressure maps of the tire's footprint. Notice how the weight disperses onto the ground here. By using an optimal kerf design, which are those strategically placed tiny slits in the tread block that give you extra traction, engineers ensure the stiffness remains completely uniform across this entire contact patch. So why does this matter to us? Because an even pressure distribution extends the life and mileage of the tire while significantly controlling frictional noise. It is visual, data-driven proof of a perfectly balanced ride.
And finally, Section 5, the Motorsport Crucible.
For our engineering marvel to truly prove its mettle, it has to graduate from the controlled environment of the test track to the chaotic, punishing world of professional racing. And this brilliantly illustrates that contrast. In the grueling 24H series circuit, tires must withstand immense heat, high-speed cornering, and relentless endurance on smooth tarmac hour after hour. Contrast that with the European Rally Championship, where tires navigate extreme, unpredictable terrain, slamming against rocks, dirt, and sudden drops. By competing in these dramatically different but equally brutal environments, the tire proves its absolute technological prowess. And the best part? The data gathered here in the crucible of motorsport directly influences the tires that eventually end up on your own personal vehicle.
So, we come to the end of our journey. From the space-age laboratories of the Technodome, through the complex chemistry of carbon black, out onto the sprawling expanse of the Technoring, and finally through the unforgiving trials of global motorsports. Every single time you drive, you are riding on a masterpiece of modern engineering. Which leaves us with one final thought. Next time you get behind the wheel, are you really going to still see just a simple rubber circle? Thank you so much for joining me on this explainer, and keep exploring the incredible world around you.